Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve a question from Mechanics 1. This belongs to paper 41, session 2024, May June. Let's see what the question says. A car of mass 1700 kilo is pulling a trailer of mass 300 kilo along a straight horizontal road. So one information, the road is horizontal. The car and the trailer are connected by a light inextensible cable which is parallel to the road. There are constant resistances to motion of 400 Newton on the car and 150 Newton on the trailer. The power of the car's engine is 14,000 watt, and we will have to find the acceleration of the car and the tension in the cable when the speed is 20 meter per second. So, this is a very common solution. All of us know how to solve this. It's actually Newtonian laws related question. That means the force. The topic of this question is force. So, we will apply the Newtonian laws of force or motion. So, let's start the solution. First, for car, as there are two objects, we will have to start with the car. For car. For car. Well, we know the Newton's the most applied formula is driving force minus resistance force is equal to mass into acceleration. Let's see what are the driving forces of the car. So the driving forces of the car is equal to power over velocity minus tension in the cable, because the car is pulling the trailer forward. That's why the tension will be negative, and there will be the resistance force on the car which is given. The resistance force on the car is given 400 Newton. So we can write 400 equals, right side is mass into acceleration. Now we will substitute the values. Power of the car was 14,000 watt. It has already been given. So 14,000 watt over V. Velocity of the car is given as 20 meter per second. So let's write 20 minus tension as well as the resistance force on the car, 400 equal to, right side is going to remain unchanged. Then we can write that if we divide 14,000 by 20, it is going to be 700. 700 minus tension minus 400. Then we know the mass of the car is 1700 kilos. So let's write 1700 A. Well, then we can do the transposition. So T is equal to, actually, T is equal to 300 minus 1700 A. 1700 A. This will be our first equation. Equation number 1. Equation number 1. Let's see what will happen in case of the trailer. For trailer, we are going to apply the same Newtonian law of motion for trailer. Trailer. So for trailer, the same formula, driving force minus resistance force will be proportional to mass into acceleration. Let's see what is the driving force. Actually, the trailer has no driving force except the tension, because the trailer was actually pulled forward by the car. That's why the tension in the cable is the driving force. So let's write tension, and the resistance force on the trailer is, how much is it? Yes, it's given 150. 150 is the resistance force on the trailer. So let's write 150 equals, mass of the trailer is given how much? 300. 300 is the mass of the trailer. So 300 A. Then if we simplify this, it is going to be T is equal to, tension is equal to 150 plus 300 acceleration, and that can be the equation number 2. So as we have already obtained both the equations, let's resolve the simultaneous equations. Let me find one new page, blank page. Okay, this is the blank page. So we will write, what was the first equation? First equation was 300 minus 1700. 300 minus 1700. So 300 minus 1700 A equal, let me erase this, equal to, what is the equation 2? Equation 2 was actually t equal to 150 plus 150 plus 300 a 300 a. Well, if we do simplification through transposition, it is going to be 300 1700 negative 1700 a minus 300a equal to, right side is going to be 150 minus 300. Well, if we do simplification subtraction, then it is going to be 2000a. 2000a is equal to 150. If we subtract 150 from 300, it's going to be 150. So let's find a. Our acceleration is going to be 150 over 200, sorry, 2000. It will be one more zero. 2000. Finally we got our acceleration is going to be, if we divide 150 by 2000, it is going to be 0. You can do this through using your calculator. 0.075 meter per second. So we have already obtained the acceleration. Now we will have to find the tension. Hence tension is equal to, tension we have already, let's go back to the formula. What was the first equation? First equation was 300 minus 1700a, or we can apply the value at any of the equations. If we apply here in the second equation, it will be 150 plus 300a. So 150 plus 300a, 150 plus 300 into our acceleration was 0.075, and if we multiply, if we do the simplification, ultimately our tension is going to be 172.2. By using calculator we can find this result directly, 172.5 Newton. So we have obtained both of the answers. They have told us to find the acceleration as well as the tension in the cable. So that's what the solution is. I think you all have understood well. Let's do the next one in the next video. See you then. Allah Hafiz.